So as you get better at logarithms, sometimes you'll just be able to read the logarithm and say the answer. Again, sort of the strategy I talked about before is log 5 of 3,125. You're asking yourself, what's the exponent? 5 to what power would be 3,125? Now, that's a big number. I think that even went beyond what we put on our powers chart. But one of the things that we're going to use, especially when you look at the last one, 8 to what power is 2 cube root of 2? That's not something that mental math's going to happen, right? It's not going to happen. So we're going to use the same strategies that we used before with our powers and our powers chart. And in order to do that, we're going to say, I don't know what this is equal to, so I'm going to make it equal to x right now. Then I'm going to use my definition of a logarithm to change this into a form that I'm more familiar with. The base is 5, the exponent is x, and the answer is 3,125. Then the strategy that we used before was we tried to change both sides to the same base. So we looked at our powers chart, and I know that this one's one beyond, I think, what we wrote on our powers chart, but it's 5 to the power 5. And then once you have both sides as a power with the same base, then we'll know that our exponents have to be equal. So x is equal to 5. So for our second one, again, we can make this equal to x. Our base is 6, our exponent is x, our answer is 1 over 216. Are those in the same column of a powers chart? Yes, 216 is 6 to the 3. Now, we've got the bases the same, but on both sides they're not a single power of 6. We have that 6 cubed on the bottom of our fraction. What exponent law can I use? On the right side. Yes, a negative exponent. So that 6 to the 3 on the bottom we can write as 6 to the negative 3. Now we've written both sides as a power of 6. And so we know that x is equal to negative 3. And finally, the last one, again, we can make it equal to x. Change it using the definition of a logarithm. The base is 8, the exponent is x. 2 cube root of 2. So when we look at all those numbers, 8, 2, and 2, are they in the same column of a powers chart? Yes. We can rewrite 8 as 2 cubed. On this side, I can use my exponent laws and write the cube root of 2 as 2 to the 1/3. So what I want to do is I want to see, is there a way that I can write both as a power of 2? Well, on this side I can use power to a power and multiply to get 2 to the 3x. What am I going to do on the right-hand side? How do you simplify 2 times 2 to the 1/3? And it's interesting because if I asked you what you needed to do if I wrote this, you would tell me right away. But somehow when it's numbers and they add a fraction in there, it's harder to see. But we are multiplying two things with the same base. And this one is 2 to the 1. Well, you could divide by 2 as well. That would help get rid of the 2 on this side. Or we can use our exponent law to say, if I'm multiplying two things with the same base, I can add my bases, add my exponents. And so 1 plus 1/3, you'd have to get a common denominator. 1 is 3 over 3, plus 1/3 makes 2 to the 4/3. If you divided, dividing wouldn't be wrong, but what you would have to do is you would have 2 to the 3x divided by 2. And then you'd still have to use your quotient rule. Because I'm dividing by the same base, I'd have to subtract the exponents. So you end up doing the same thing, and it's just easier to add them to begin with. Now I've succeeded in getting both of them to be a base 2, so that means that 3x has to equal 4/3. In order to solve for x, we have to divide both sides by 3. Dividing by 3, especially when working in fractions, do you know that dividing by 3 is the same as multiplying by 1/3? So if I multiply this fraction by 1/3, I get 4/9. Now, I don't know how you'd like to do this, but I'd like you to put a star beside this one. I know that when I give you the pre-quiz for 5.4, sometimes the method that when you have ask for help, when you hit that ask for help button, sometimes they do a little bit of a different method. This is one of the examples that I believe they have a little bit of a different method, and I believe it's a little bit more confusing, in my opinion. This is nice because all we're doing is exactly the same thing that we did earlier in the unit and practicing that. So I think that is a better strategy than trying to learn a bunch of new strategies. To use the same strategy over again makes life a little bit easier. So maybe you want to watch this video again if you get stuck on these when you're on the pre-quiz, as opposed to hitting that help button. Anyways, I'm going to give you a little bit of time to try some of these right now. 4, 7, and 9.